think it would be a nice time to step back and talk about what does it look like to follow a rule versus apply an idea, because they are very different things. So here's my example. I think you know how to solve this from last year. Give it a shot. What do you think the answer is? That's right. The answer is x could be 2 or x could be -3. Both values satisfy the equation. I imagine that a lot of people learn this kind of problem as a rule, a pattern matching rule. So like I see a problem that looks in a certain way, and that means I do a certain action. If that's the way that you've been learning math in the past, it's really not a very good way, and I'll tell you why. One reason is I can write a computer program that follows rules better and faster than you can, better and faster than I can, better and faster than any human can. So if all you learn in math class is how to follow rules, you've just turned yourself into like a really slow, inaccurate computer, and like it doesn't really seem like there's very much use in doing that. The second reason is you'll only be able to solve the exact same kinds of problems you've seen before, and life doesn't have very many of those problems. Or rather, I guess it does, but they're problems that we use computers to solve. So like all of the interesting questions are ones that look different from problems that humans have solved before. So like that's the kind of thing that you want to be training yourself to be able to solve. And the last one, maybe more immediately, is that you will get confused and or fooled. And here's what I mean. In Algebra 2 Trig, when I taught it, I would give questions like this, and students would look at this, and they'd misapply the rule because they weren't paying attention to a detail. They said, oh, this looks like, x is probably 2 or x is -5, and they would declare themselves done and happy because they weren't thinking about what they were doing. They were just mindlessly following the rule. And of course, that doesn't work. And then they'd look at this problem and they'd think, oh my gosh, that does not look at all like the pattern for anything I know how to do. And they would just say, I don't know how to do this one, sorry. So rather than following a rule, the idea that applies here is the idea that if you are multiplying a bunch of things together and you end up with a 0, logically you can conclude that one of those things has to be 0. Because the only way that you can get the entire product to be 0 is if one of the things you're multiplying is already 0. And so that's what lets you take the big thing and break it into multiple parts. So that's what lets you split it up into the different things and say either A is 0 or B is 0 and so on. So that's the pattern you want to recognize, but it's going to look in very different ways because each of these parts might look quite different than what you're used to. Like the important feature you want to be attending to is the idea that you're multiplying a bunch of things that end up to be 0. So for this problem, you might recognize that you've got a thing times a thing equaling 0. But you might think, wait a minute, divided by 3, that doesn't really seem to fit, or does it? And so then you think about whether or not the concept actually applies in this situation. So you'd think, all right, I've got a thing times a thing divided by 3 equaling 0. So is it still true that one of those two things has to equal 0? And if you think about it by plugging in some numbers, I think you'll see that yes, this can only happen if one of those two things is 0. So if you understand the underlying idea, you can still check to see if it applies to new situations. So now I know that either e to the x is 0 or x plus 7 to the 14th equals 0. And now you can try and solve each of these things. Here you might realize that e is a number, so it's like 2.71. So you can't raise any base to a power that will make it equal 0. So it's just impossible for this part of it to equal 0. Therefore, if there are any solutions, you know that they have to come from this part. So here the 14th power shouldn't freak you out because you know that if what's inside isn't 0, then raising to the 14th power isn't going to suddenly make it 0. So it's like the 14th power doesn't really matter. It's like if this whole thing is going to be 0, it's only going to be 0 if x plus 7 equals 0. So x could be -7. And so now you've figured out your answer. So I hope what you're noticing here is mostly what I'm doing is logical thinking. It's not like following mathematical rules. It's applying a mathematical idea, but then using a lot of common sense and thinking about what's possible, what's impossible. Like, would this thing apply in this situation? Would it not? So that's the kind of thinking that I'm trying to get you to start applying in all of the problems that you do. And those are like most of my learning targets. So when I create videos for you, if you're trying to find like what's the thing I look for and then what's the thing I do afterwards, if you're trying to learn by finding pattern matching rules, I'm intentionally trying to prevent you from doing that because it's not a useful thing to learn. Most of the time. There are like a couple, and I'll tell you when those are happening. But mostly what you want to be focusing on is what's the idea, and how do you know when the idea applies or doesn't apply. So I hope this has been clarifying for the approach to this class. Thank you for listening.